Thank you, Jason. Right, good afternoon, fellow educators. I shall be sharing on how the use of spreadsheets can enhance students' appreciation of the concept of linear law. We use Microsoft Excel as the tool to deliver this package, but other spreadsheet tools can be used as well, such as Numbers by using Apple products or Google Sheet as well. All right. So in our lesson package, there are 3 goals. First is that students are able to convert non-linear equations to a linear equation. And number 2, students will use spreadsheet to create plots of non-linear data set and its corresponding linearized form. And lastly, to be able to connect linear law to real-life applications like Fuchs law, radioactive decay, and even calculating the half-life of Panadol, for example. All right, I understand that we have a couple of colleagues here who are not maths teachers. So to explain a little bit of what linear law is about, it's a mathematical technique that converts non-linear relationships into a linear form, allowing them to be analyzed on a straight line graph. For example, if we have a quadratic equation y equals 3x squared, and we take log on both sides of the equations, we can get this equation, log y equals to 2 log x plus log 3. And then we express big Y, which is log Y, equals to m, which is 2, and log x, which is big X, and c, which is log 3. Okay, creating a linear equation, y equals to mx plus c. This transformation is useful for identifying relationships and determining unknown constants in experimental data. In Singapore, linear law is actually taught in high school, secondary school, year 4 for Sec 4 students. It is part of the additional mathematics syllabus. All right, for lesson outline, I will give you some context, okay, of this lesson package. Before this lesson package, right, real-life application to determine the half-life of Panadol is given as a prelude for the topic to generate interest, to let students see that, hey, this topic is actually pretty useful. After that, the lesson package is conducted when students have achieved basic content of linear law using our in-house loads. All right, and in this lesson package, students will learn experientially how to apply linear law and why it's practically useful. And questions following Socratic style will pepper throughout the activities in order to promote active learning. Right. So first, this deck of slides was created actually to help students see that linear law can actually be pretty useful. All right. In the interest of time, I understand that, and I also understand that some of us are not maths teachers here. When we have a relationship between the concentration in human body of Panadol, after 1 gram of Panadol is ingested, they are presented with a graph of concentration versus time, and they see that it's not a linear graph, and they're asked to determine certain value of constant K, which is known as the elimination rate constant. Essentially, they will see that it's pretty tough to do so, still possible, but when a corresponding linear graph is generated, the value of K can be found rather easily. Right, and this entire application is actually generated by ChatGPT. So teachers don't really have to spend extra time doing it, they just need to make use of it and show students. Now, we can also use it to generate other examples rather quickly. Let's say we don't want to use half-life of Panadol to trigger students' interest. We prefer to use something more benign because Panadol is a drug after all. We can consider triggering student interest with a question like why nutritionists recommend not to drink caffeinated drinks after 3 p.m. Yeah, and we can actually get data showing how after caffeine is ingested in the body, how fast it disappears in the human body, and from there calculate the half-life of caffeine. Now, after students have a basic knowledge of linear law using our in-house notes and done some practice sums that are equivalent to O-level standard questions. We will conduct this 1.5-hour lesson using Microsoft Excel. Okay. They will be using their personal learning devices, but we also work collaboratively in pairs. Okay. Just give me a little bit of time here while I switch to the actual activity. Right. Okay. So students will be using these actual slides here, except that this is a teacher's version, and I'll show you how the student's version is a little bit different later on. Okay. So in the first step, right, the objective of the lessons are stated. Now, and we also attach a few articles for them, including what Hooke's law is, and Boyle's law, and so on. They can read the articles if they are interested, but students can also direct them to relevant equations in the article. They don't really need to know these physics concepts. And in the second tab here, we show students that, hey, actually linear law and spreadsheets can be important if they decide to take A-level H2 physics. Okay, but it's fine if they choose not to take physics as well. Spreadsheet is also a rather useful skill that they have. And third step, in the third tab here, we show the relevance of spreadsheet. Okay, and you show them step-by-step instructions on how graphs can be plotted in Excel. Now, it may come as a surprise. Our students may be savvy using smartphones and social media, but many are not familiar with the use of spreadsheets. Okay. And then we lead them through a basic exercise in plotting charts, straight line graphs, before going to what we call the anchor activity, which is in this fifth tab here. Okay. As can be seen here, there are certain cells that are highlighted in yellow, and these cells are actually empty for students to fill in. Okay. In the top left-hand corner here, we have a table. All right, it shows the amount of radioactive substance in the body, represented by this letter N, versus the number of hours of that this radioactive substance is left to decay. All right, and we ask students to fill in this table of ln N. All right, and we ask them to plot a graph of N against T. Okay, so students would insert their graph here. They will not see the graph here. When they plot it, this is what they would see, and they will find that it is not a linear graph. Okay. Now, and they will be asked what kind of graph is this. Students would be able to tell us, and they'll probably guess that it's an exponential decay graph. All right, and we may ask them an additional question. Is it possible for this graph not to be an exponential decay graph, but to be a power function graph, for example? And we would want them to think through it, because a power function graph looks similar to an exponential decay graph with some differences. Okay, and we hope that they will be able to verbalize them, and we'll explain to them why this graph cannot be a power function graph. Okay, one of the reasons being that a power function graph would not be able to start from the part where a horizontal axis is 0. It should not be touching the y-axis. Right, and we also ask them several questions, and we hope that we'll be able to deepen their ability to relate theoretical mathematical relationship with a real-life scenario, and to be able to communicate understanding both verbally and in written form. As students continue to ask these questions here, they will begin to understand the concepts and practicality of the linear law deeply. Okay. So the part where students are asked to convert the exponential function into one that is linear is over here. After which they will plot the linear graph. Again, they will not see this graph here, but they're asked to plot it. And then we will ask them various aspects of the graph. All right. Now, I think as can be seen here, while we put a fair bit of emphasis on linear law in this series of activities, students also learn general spreadsheet skills. Okay. At the same time, they will be able to see that linear law usually doesn't exist in isolation, but is often related to other mathematical concepts like quadratic equations, exponential functions, and so on. And they should be able to relate them to real-world applications, okay, in the pharmaceutical industry, in radiation, and so on. Now, in a 1.5-hour lesson, we are usually able to cover up to complete this anchor activity fully. However, we do have additional activities for students who are interested to explore linear law further or to do an exercise on their own. This activity here is on Boyle's law, you usually skip. Okay. And lastly, we round the lesson by asking, through this activity, what students have learned about linear law that they find useful. Now, let me just go back to the slides to share some takeaways. Students are generally engaged and the learning objectives are met. Just like in a typical class, where students' ability to learn and use spreadsheets can vary pretty widely. And therefore, it's useful that they actually sit in pairs, where sometimes there will be someone who is stronger who can help the weaker student. All right. As mentioned earlier on, Microsoft Excel was used to deliver a lesson, but other spreadsheet tools like Google Sheet and Numbers can be used. And lastly, which I thought is rather important, is that teachers who intend to use such activities, we must be mindful that what students see, okay, what students see on their screens, and what teachers see may be different, and that students may have limited spreadsheet functions in their devices. So if a teacher intends to use Microsoft Excel to deliver the lesson, then he must ensure that he uses a student's device and run through the lesson to see that they can actually do the same things, perform the same functions. All right. With that, I end my sharing. And do we have time to open to questions? Right. Any questions?
Maybe just let me start the ball rolling. I can see that the lessons use quite a bit of Excel, and there's this deliberate effort for the teachers to pair the students up so that students who are not very proficient in using Excel, they have some help from their friends. So I'm just wondering, because when I was sitting in listening to the lessons, right? If I'm one student who has not used Excel, I may be too overwhelmed by the Excel and lose focus on the content. Yeah. So I'm just wondering that pairing that you all have done in class, is it useful, or actually there are still a lot of students who are still very caught up with the use of Excel rather than focusing on the content?
Okay, testing. Can you hear me?
Yes.
Yeah. Okay, so maybe I just share from for my part first on the use of spreadsheets for partial fractions. Okay, so in terms of the grouping wise, okay, they predominantly follow the group that they were in for their group project, because they were doing a group project for math lah. Okay, and as I mentioned earlier, actually all of them have been taught how to use spreadsheet formulas. Okay, but based on my experience, even so, of course, as with any coding activity, right, if you have to do something like this on the spot, you may know the formulas, but it will take some time to actually process in your mind what is the kind of formula that I need to put in now. Okay, so I would say the purpose of the group setting is also for them to talk to each other, okay, to help each other, because all of them are in a sense kind of struggling. Yeah, but maybe in retrospect, perhaps one thing could have been done is to have a warm-up activity prior to the lesson for them to do asynchronously first, because even though they had already learned spreadsheet formulas and how to use them, the last preceding activity prior to this one was actually a few months back. Yeah, so maybe that would have helped to be a bit quicker, okay, into adapting to what the task required from them. Yeah. Okay. Yeah. Then pass to Yahoo to answer for his part. Yeah.
All right. Just to add on, right, for students in NJC, and on maths classes, generally they would have learned how to use spreadsheet, right, and create formulas since stage 2. So in Sec 2 and Sec 3. All right. So by the time they come to Sec 4 and run this linear law lesson, I think the majority of students would have some basic idea of how to use spreadsheet functions. So generally, we wouldn't have that much of a challenge doing that, because it's not the first time they are doing that. Sorry, can you hear me? Okay. Now, having said that, right, if they still encounter problems, that's where the pairing comes in. We do not have any specific way of pairing the students up. It's just their shoulder partners. And should they need further help, the teacher is actually walking around the class to support them. So so far for in the few classes that run this activity, we don't really run into such problems where students have difficulty plotting the graphs. On top of that, we also have a warm-up activity already earlier on. I think as mentioned earlier on, in one of these students are actually taught how to plot a straight line graph using Hooke's law as an example.
Thank you, Yahoo and Jason. So let's maybe hear from the audience if there's any thing that they would like to clarify based on your sharing.
Hi, Yahoo. Can you hear me?
Yeah, I think
Yeah,
Jing,
okay.
yep.
Wait, I just wanted to ask, like, when do you all teach linear law again?
When do we teach linear law?
When do we teach linear law?
Yeah.
We teach linear law when they are JH4.
Oh, okay. Because I was wondering, because Hooke's law is taught at GH3, and then yeah, and we do quite a bit of like the equations of motion at this point, like at GH3. So I'm wondering how to help students see relevance between what they learn in physics and math. But bearing in mind that there might be students who are not doing physics. So I understand that there's a tension between drawing too much links with physics, because the bio students will be a bit lost. But I'm thinking that I think physics students will appreciate seeing a connection between what they learn under linear law. Yeah. And I was wondering, for linear law, you teach the log. You teach the log function. Do you teach linearization?
Linearization?
As in, like, if it's y equals to x squared, and then they will log it before they plot, instead of putting x squared as the x.
We teach both.
Okay. Because for our practicals, we always do that method. Like we don't use a log function at JH lah. Yeah.
Okay, I think you raised a valid concern earlier on regarding the non-physics students, which is why in our activity we are mindful that students need not understand Hooke's law, and teachers can actually point out the particular equation that we'll be using. Why we
So
put Hooke's law
I'm
there?
curious, do the physics students actually realize that they have learned it in physics?
Oh, that's a very good question. I think we should ask them next time around.
Okay. Okay.
Yeah, I think the Hooke's law, Boyle's law, is to bring context in. To help them realize, okay, there's actually a relationship between maths and the sciences and real-world applications in general.
Okay, thank you.
Actually, I see value in using Excel to teach linear law, because I think even when I was a student, I have always have this question, oh, why is it that when I take ln on both sides, this becomes a linear equation? Yeah, so actually with the use of spreadsheet, when the students use Excel to plot the points on the graph, they actually see that the points are now lined up in a straight line. So I thought in a way we can use this to help convince students why, you know, when we apply the linear law, the points, the data is actually linearized. Yeah, because when I was a student, I was thinking, when we take ln on both sides, isn't ln a non-linear function? So how has that become a a linear function? Yeah, so I see merits in using Excel so that the student can see for themselves the data points has indeed become linearized. Right. I think Mrs. Stowe raised her hand. So yeah, Mrs. Stowe, please.
Hi, colleagues. Yeah, I really enjoyed the presentation, though of course I had trouble following much of it. I just wanted to share an anecdote which might interest you, gentlemen. I was a pretty, I mean, I did H2 maths, but I was an art student, and so I think I learned a lot of my maths in a very rote fashion, and of course, maths at the time was not as perhaps as conceptual as it is now. But as a young working adult in beginning teacher, that was my first experience using Excel spreadsheets, and it gave me the chance to understand algebra in ways that I hadn't understood. And I thought that some more simple uses could be done as well with possibly younger students. So even just, I mean, just to show the level of my maths knowledge, and somehow I managed to do okay for H2 maths, I really struggled to understand the concept of independent variables and dependent variables, and the idea of function x and x, and the just so as a young BT, I mean, I was a literature teacher, but I was tasked to carry out a survey in the school, and then to process the survey data. And so I had to teach myself how to use Excel, how to write equations in Excel, how to turn tabulated data into charts and so forth. And that whole process, I found that I'm learning my maths again and understanding the relationship between my independent variables and my dependent variables, the whole idea of function x and x. And yeah, so I was like, wow, it's a revelation. And I guess because it was an application of the maths. And so I just want to say, I think what you're doing is very important. And as you know, we use Excel the whole time, right, as working adults. And if the kids can feel comfortable to use it, for some of them, it might actually help them grasp even much more basic mathematical concepts better than they do right now. Thank you so much.
Thank you. Thank you, Mrs. Stowe, for your comment. Yeah.
Right, we welcome more comments and questions from the audience.
I believe we have participants here from a couple of other countries, from Russia and from Thailand. We're very, very encouraged that you have joined our session here with the NJC community in Singapore. Thank you so much for your support.
Right. Maybe while the rest are still thinking about what questions they want to ask, Jason, would you like to share some of the reflection that yeah.
Okay. Yeah. Okay. So as I mentioned in my lesson outline, okay, actually I post them a series of reflection questions. Okay, let me just bring up the relevant slides. Okay, yeah, so in the online form, these were the questions that I posed to them. So first of which, okay, I asked them, okay, what benefits do they see, you know, from this activity? Why is it so good or so useful to use spreadsheets to automate the problem solving process? Yeah, okay, and then following which, okay, I asked them, you know, what other kind of problem types or real world contexts might they see where such an automation may be applicable for? Okay, and then lastly, what other programs or apps can we use to automate or algorithmize such problem types? Okay, actually, since we have some time, I will just show you a short video, okay, on the students' responses, because after they fill in the form, I actually got some of them to share their responses. Yeah, okay, so that.
More efficient to use Excel for the partial fraction decomposition as compared to what? Or doing manually. Okay. Okay, can? Yeah, so a lot of problem types you learned before, even earlier in term 1 where we did the quadratic inequalities. Okay, you see this is a very efficient way lah. Okay, so there are benefits. Next time, you know, you go to the workforce or whatever, you can also do something similar. Okay? Ryan, anything to add on? How about for question 3? Huh? Python, anything else? No, I thought recently you've been learning something else. That one not so useful, is it? Okay, can. Okay, thank you. Any response for question 2? Keelan, question 2?
What?
Question 2, quickly. Last one already.
Supply chain.
Supply chain. What do you mean by supply chain?
Because when you're working as a manager in supply chain, you gotta handle a lot of different things coming in and out. So to calculate, to get the inventory right, you need all this.
Yeah. Okay. Yeah. So, and as you can see, you know, these are the kind of responses that the students gave lah. Okay. So, wait, the slide came up. Just give me a moment. Okay. So, here are the form responses. Okay, from the other students also. Okay. So as what one of the students mentioned in the earlier video, okay, and also what a lot of students correctly pointed out from their form responses. Okay, so using the benefit of using spreadsheets to automate the problem solving process can help to make the process more convenient and efficient. Okay, and then as for the second question, okay, what kind of problem types or real world context might they find this to be useful for? Okay, so there were a variety of responses. Okay, so some students mentioned things like management of finances, accounting, event planning, and essentially any system related processes. And sometimes you may also get surprising responses from the students, like what the student mentioned earlier about supply chains, yeah, which was not very expected. Yeah, okay. And lastly, also a lot of students correctly pointed out that there are other programming languages that we can use instead of Google Sheets. Okay, so I think one fairly common one would be the use of Python programming language. Yeah, so these were the reflections that the students had from the activity. Yeah. Okay.
All right, thank you for sharing the reflections. I think it is really important each time when we have some lesson activities for the students to have a chance to reflect, because otherwise it will just be doing and doing rather than thinking about what they're doing and appreciating what they have learned. Yeah, right. So do we have any comments from anyone or questions for these two gentlemen? Right, Shanshan, yes.
Hi. I have a question that I would like to maybe invite everyone to chime in. One of the observations that Jason noted was while the intent was to get the students to collaborate, he found the students going into a divide and conquer mode. So I'm wondering, all the educators present, what is your tip to push the students towards a more collaborative mode as opposed to a divide and conquer mode?
I think I can share like for GH Science, we especially when we do perspect tasks, right? We do during the group discussions in class, we get them to assign people in the group, each person to take on a specific role. So there's one person who is the scribe. There's one person who is the, sorry, I can't remember the names we use, but someone who is like the challenger. So someone needs to be intentionally trying to ask questions or challenge the person who says something. So I think with these specific roles given to them, it does force them to converse and collaborate more, rather than just divide and conquer. Yeah, so I think that was one useful tool. But that said, that is useful. It has to be started in the classroom first. Because if you ask them to do this on their own, they will go back to their default mode of splitting the work. Yeah, so I think some monitoring at the beginning to get them into that culture of, different people have different roles in a discussion, and to talk to each other. I think that will be helpful. Yeah.
Oh, this is told.
Yeah, just to add on, I thought just now when I was viewing the videos of the lesson that there was one time when the boys were collaborating, I think partly because they were all on the same screen. And so I've also noticed in PW that I've had to, as I got a little frustrated with the students always looking at their own individual screens, no doubt they're all on the same document, but they're not making eye contact with each other. And sometimes, even though they're on the same, all looking at the same spreadsheet or document, they're looking at different parts of it, right? Whereas if they're all gathered around one device, or if they're having a discussion and one person is allocated the note taker role, like Jingjing was saying just now, then they're going to be more collaborative. So I got to the point where I required them to face down their iPads, with the exception of one person who was on the document and serving as note taker and recording the discussion. So I think some of this kind of draconian pedagogies may be necessary.
I wonder if our colleagues from other schools, maybe Carrie or Hui Chun.
Hello.
Hi.
Hi.
Hey.
Hello.
What time is it over in Camborne?
It's 8:20 in the morning, so
All
early
right,
morning
good
here.
morning.
Yeah, good morning. So I find it really interesting because actually we don't necessarily deliver our math. I mean, I'm a science teacher, but I know our math teachers, they actually don't have ICT facilities in delivering some of this stuff. So I actually wonder how we would ever be able to incorporate it into the current curriculum that we have for our students. So this might be something that we would do potentially as like a co-curricular and additional activity that the students would do outside of their sort of normal maths lessons. But it's amazing to see, and it's such a shame we don't have these resources to use. But yeah, it's been really interesting. So thank you so much.
How do you get your students to collaborate more than, you know, when you give them a group task and then they just go and do their individual pieces? What's your little trick?
So it's a lot. So particularly with our older year groups, with our sort of I don't know what grades they are, but with our sort of our students that are 16 years and above, they can do a lot more collaborative work, and they'll be able to use the IT systems. That our lower years, it's very structured, so they will be given a task to do, and they'll be given a time frame to do it, and then it's kind of a turn, have a discussion, and then they go back to silence, and they'll work individually.
I wonder if Wee Chun, it's free to chat with the group.
Oh, sorry, our school bell is just going off. I missed that. Could you repeat it for me, please?
No, it's fine. It's fine. You milked it before we all were listening to the bell. Yeah.
Sorry.
Yeah. What about the colleagues from other schools? Mrs. Lee, Wee Chun. Oh, my apologies. Shocking just mentioned to me that obviously they are colleagues in the school that I don't interact with. What, Wee Chun teaches math as well? Okay. Ah, Joyce, our econs teacher. No, math teacher. Okay. All right. So what I gather is Jinjing was sharing by assigning roles to respective people, so that they all are obliged to do a certain thing within the group, and then they need to converge together. And then Mr. Stoll shared that maybe one screen is better than everybody having their own screen. Maybe it's not such a good thing when it's so efficient and everyone dividing and looking at different parts of the document, and then Carrie was sharing, giving them a time frame and then coming back to the task. Are there other questions? Any questions from you, Xiaoking or Jason? Anything, any feedback you would like from the audience?
I think first of all, thanks everyone so much for the comments and the questions. Yeah, I think my take for the concern about the collaboration versus the divide and conquer is that I think to a certain extent, some dividing and conquering is still fine. Right? I mean, there will definitely be parts that they may have to first think through individually what needs to be done. But I think after they are done with that stage, they should come together and bounce their ideas off one another and you know, leverage each other's idea, comment and say that, hey, that's a good idea. How come I need about that? Or maybe you can do it in this way. Yeah, so that's when the collaboration can still come in. So maybe like the structures that Qing provided or structures that the teachers put in place to tell them, okay, you must do it after you've done the individual part, you must come together to discuss and choose who's the best one and justify. Yeah, these structures, if we put in place, then you will make the collaboration part more, it come out more. Yeah. Thank you.
Yeah, sorry, I just unmuted myself. All right, thank you everyone for your comments and questions. I think this has been a very fulfilling 1 hour learning from our 2 colleagues on the use of spreadsheet. If we have no further questions, then I think this session will come to a close. Now, for those who want to just stay on and want to mingle and have more questions to ask the 2 gentlemen, you are free to stay back. If not, yeah, thank you very much for spending the last 1 hour with all of us. Yeah, bye-bye.
Thank you. Bye.
Bye. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.